At their basic definitions, fractions are parts of a whole. They tell you how many parts a whole is broken into and how many of those parts you are representing. When we talk about wholes, we talk about a whole item, a whole object. Things like pies, pizzas are used common. Puzzles, because we have one whole puzzle put together, one whole pie before it's cut, one whole pizza before it's cut. Then we cut those things or take the puzzle pieces apart to show that a whole is made up of individual parts. When we look at just a handful of those individual parts, we have fractions. We have part of the whole. The anatomy of a fraction helps to define what a fraction is. The numerator tells us how many parts you're representing. So these are those individual slices, those individual puzzle pieces. The denominator tells you how many equal parts the whole was broken up into. This is how many pieces the pizza was cut into when it showed up at your door. This is how many slices the pie was cut up into before it was served. This is how many puzzle pieces are in the box. Let's go back to the puzzle example. In this case, it's a puzzle that has 6 pieces. That means the whole was cut into 6 pieces. This picture was cut up 6 ways at the factory. We only have one puzzle piece down in the upper left-hand corner. That means I have 1 out of 6 pieces. In the next example, I put down 2 out of the 6 puzzle pieces. I have 2 in my numerator because 2 of the individual pieces are represented out of 6 whole pieces. Here we have 3 out of the 6 represented, so 3 6. Here we have 4 out of the 6 represented, 4 6. Here we have 5 pieces represented out of the 6 in the set. If we have all 6, then we have a whole. In other words, if your numerator and denominator are the same, you have one whole puzzle. 2 6, 3 6, 4 6, and 6 6 are all what we would call unsimplified fractions. Although they represent the situation well by telling us there's 6 pieces in the whole and 2, 3, 4, or 6 specific pieces that we're looking at, they are not helpful for calculating further. In that case, we would need to simplify the fractions. Let's look at what a simplified fraction is first. When you cannot divide any other number other than 1 out of the numerator and denominator, the fraction is in simplest form. Look at the examples below. Try your best to divide at any number, even one value, out of both the top and the bottom. So for example, 12 fifteenths. 12 fifteenths is not in simplest form because I know I can divide 12 and 15 by 3. The number that you would typically divide out of your numerator and your denominator to simplify is called the greatest common factor. The greatest common factor, or GCF, is the biggest value that can be divided out of 2 or more numbers. So this doesn't always just apply to fractions, but it has its biggest use in the world of fractions. To describe the greatest common factor, you need to look at it like having 2 crushes. Think of the school-appropriate characteristics that your last 2 crushes represented. So for example, I might say with my last 2 crushes, the first one had a sense of humor, liked horror films, had curly hair, and was a Cubs fan. Those are the characteristics that defined or made up that particular crush. The factors that made up crush number 2, well, they had a sense of humor, they were afraid of horror films, they were also a Cubs fan, but they had short hair. These 2 lists of factors represent each of my crushes individually. If I look for the common factors and combine them, so someone with a sense of humor and is a Cubs fan, that would be the greatest common factor of both my crushes. So in this case, it would be what I would call my type. So once you've listed out your crush's factors, circle any words that were in both lists. These things are the greatest common factor among the factors that make up your crushes. When finding the GCF of 2 values instead of 2 people, we list the factors that multiply together to make the individual values. We do this by looking at our divisibility rule. Although a calculator can be very helpful while simplifying fractions, divisibility rules are a great mental math trick. If the last digit is even, I can divide by 2. If I add up the digits that make up the value, so let's say 12, 1 and 2, 1 plus 2 is 3. If that sum is divisible by 3, then the whole value is divisible by 3. If it's even and the quotient you get from dividing by 2 is even, then it's divisible by 4. So 8 divided by 2 gives me 4. 4 is still even. So 8 is divisible by 4. 5 is simple. The last digit is a 0 or a 5. 6, both the rules for 2 and 3 have to be met. 7 is very complicated. For 7, it actually comes out a lot simpler to memorize those factors of 7, or those multiples of 7 in this case. 8, the rules of 4 and 2 both have to follow. 9 works similar to 3. Add up the digits. If that sum is divisible by 9, then the whole number is divisible by 9. 81, for example, 8 plus 1 is 9. 9 is divisible by 9, so 81 is a multiple of 9, which means it's divisible by 9. 10, it always ends in a 0. In order to find the greatest common factor, we're going to use methods called either double mountain or single mountain methods. They're really just two great ways to find the greatest common factor by listing out all of the factors in order in a logical way. You always start by finding the factors of all your numerator and your denominator. So the double mountain, I'm going to find a list for 12 and a list of factors for 45. 1 times 12 makes 12. Numbers on opposite sides of the mountain multiply together. Now you don't have to put in mountains. You can just draw a big angle up and an angle down. That's all you need. Now I'm going to climb the mountain. 12 is divisible by 2. 2 times 6 gives me 12. 12 is divisible by 3. 3 times 4 gives me 12. I climbed the mountain in order 1, 2, 3 by using my divisibility rules. I could also use a calculator. 12 divided by 1 gives me a whole number. 12 divided by 2 gives me a whole number. 12 divided by 3 gives me a whole number. Any number that gives you a decimal is incorrect. It's not a factor. It has to give a whole number. Now the next number I would have checked was 4, but it's already on the other side of the mountain. Not only does this method put the factors in order, but it tells you when you've found all of the factors. So let's try it from 45. Always start with 1 and the number. 45 divided by 2 gives me a decimal. It's not divisible by 2. 45 divided by 3 gives me 15. 45 divided by 4 doesn't work. 45 divided by 5 gives me 9. 45 divided by 6, 45 divided by 7, divided by 8. Nothing works until I hit 9. 9's on the other side, so I already have my factors listed out. With them in order like this, I can find very easily the greatest factor in both lists. So I go from right to left, greatest to least, and scan the lists. The biggest value in both cases is 3. Both of them have factors that are greater than 3, but they're not common. They also may have other factors that are in common. They will always have a common factor of 1, but that doesn't mean that that factor is the greatest. The single mountain method can also be used if you want to save a little time on your work. We're only going to find all of the factors of the smaller value amongst the numerator and denominator. The going theory here is that usually, not always, the smaller value is going to have less factors. So I'm going to look at just 18. I'm going to do the same thing. 1 times 18 gives me 18. Now I'm going to climb the mountain. Is 18 divisible by 2? Yes. 18 divided by 2 gives me 9. Is 18 divisible by 3? 18 divided by 3 gives me 6. Yes. 18 divided by 4. Again, the calculator method, just see if you get a decimal or not. 18 divided by 4, decimal. Move on. 18 divided by 5, decimal. Move on. 18 divided by 6. Oh, 6 is already on the other side of the mountain, so I found all of my factors in numeric order. Now I'm going to take and divide the other value. So we used 18, now we're going to look at the other value, 27. Divide each of these factors starting with the greatest factor in the list. So I'm going to take 27 divided by 18, decimal. Again, for it to be a factor of both 18 and 27 means I should be able to divide both top and bottom by that number and get a whole number. 27 divided by 9. Hey, that gives me a whole number. That means my greatest common factor in this case is 9. So the greatest factor that will divide into the whole number is the GCF. Finding the GCF is the hardest part of simplifying a fraction. So we always start by finding the GCF between the numerator and the denominator. For 18 over 30, I'm going to use the double mountain method. So I'm going to find all the factors of 18, all the factors of 30. I always start with 1 and the number, so 1 times 18 makes 18. Then I check my divisibility rules in order, 2, 3, 4, etc. as I climb the mountain until I hit a factor on the other side. 18 divided by 2 gives me 9, that's a whole number. 18 divided by 3 gives me 6, that's a whole number. 18 divided by 4, decimal. Divided by 5, decimal. Divided by 6, that's a whole number. And we're already on the other side of the mountain, so I know I have all my factors. Do the same thing with 30. 1 times 30 is 30. 30 divided by 2 gives me a whole number, 15. So that means 2 times 15 makes 30. 30 divided by 3 gives me a whole number, 10. 3 times 10 gives me 30. 30 divided by 4 gives me a decimal. 30 divided by 5 gives me 6. The next value I would be dividing by is 6, so I'm on the other side of the mountain. I have all of my factors. Once I have both lists of factors, I'm going to scan from biggest to smallest. All the bigger factors are on the right side of the mountain. All the smaller factors are on the other side. So if we go right to left, we'll find the biggest. In this case, it is 6. Again, in both lists of factors, there are factors that are greater than 6, but not common. In both cases, there are factors that are smaller than 6 that are common, but they're not the greatest. We need to find the GCF, the greatest common factor. Once all that's taken care of, I just divide the numerator and denominator by my greatest common factor. 18 divided by 6 and 30 divided by 6 is going to give me 3 over 5, or 3/5. If you ever want to check to make sure that you're correct, and you should, 3 and 5, neither of them have factors in common. The biggest number that I can divide out of 3 and 5 is 1. And in this case, it's because both of them are prime. The only factors that go into 3 are 1 and 3, so 1 in itself. 5, the only factors that go into it are 1 and 5, 1 in itself. That's the definition of a prime value. Let's try a couple examples together. So in this case, I'm just going to do the single mountain method. So I just need to draw an up angle and a down angle. I'm going to start with my smallest value, so 15. 1 times 15. 15 divided by 2 gives me a decimal, so 2 doesn't work. 15 divided by 3 gives me a whole number, 5. 15 divided by 4, decimal. 15 divided by 5, well, 5's already on my list. So now I need to test by using division which of these factors divides evenly into a whole number out of 27. 27 divided by 15 gives me a decimal, so that's no good. 27 divided by 5 gives me a decimal, so that's no good. 27 divided by 3 gives me 9. So 9 is my greatest common factor. I'll divide top by 9, top by 3, bottom by 3. 15 divided by 3 gives me 5. 27 divided by 3 gives me 9. On your own, try 28 30-seconds and 42 56. Find the greatest common factor and then simplify. These are separate skills that work together. Brainstorm other methods that you have used in the past.